Welcome to Tech with Kaushik. This is part 1 of our complete practice question series for the AIF-C01 AWS Certified AI Practitioner exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 1. Question number 1 is a good test of exam judgment. This one tests your understanding of classification metrics. Focus on the requirement that drives the design choice. A manufacturing company trained a machine learning model to detect physical defects in product images. The engineering team needs to report the total percentage of correct predictions made by the model. Which evaluation metric should the team use to measure this performance? Focus on which option satisfies the complete requirement. Option A, root mean squared error, RMSE. Option B, R-squared score. Option C, learning rate. Option D, accuracy. The correct choice is D's, accuracy. Here is the reasoning that confirms the answer. Accuracy is the standard classification metric used to evaluate the overall proportion of correct predictions, both true positives and true negatives, made by a model, making it the right choice for calculating total percentage correctness. The remaining options fail one or more requirements because A. RMSE is a metric used for regression models to measure the average error in continuous numerical predictions, not for classification. B. R-squared is a statistical measure for regression models that indicates the proportion of variance in the dependent variable explained by the independent variables. C. Learning rate is a hyperparameter set before training to control how quickly a model updates its weights. It is not an evaluation metric. Remember this decision rule. Remember that classification tasks use metrics like accuracy, precision, and recall, while regression tasks use metrics like RMSE, ME, and R-squared. Let's analyze question number 2. Review the scenario and identify what must be achieved. An organization is deploying a machine learning model using Amazon SageMaker. The application handles large input payloads up to 1 GB and requires processing times that can take up to an hour. The system must process requests as they arrive and notify the client when the long-running inference is complete. Which SageMaker deployment option is designed for this workload? Check each option against the exact requirement. Choice A, asynchronous inference. Choice B, real-time inference. Choice C, serverless inference. Choice D, batch transform. The best answer is A, asynchronous inference. The key clue points here because Amazon SageMaker asynchronous inference is explicitly designed for processing large payloads up to 1 GB and handling long processing times up to 1 hour. It queues incoming requests and can send SNS notifications when the inference is complete. B. Real-time inference is suited for payloads under 6 MB and sub-second latency requirements, not long-running jobs. C. Serverless inference is for intermittent traffic with short execution times and smaller payloads. D. Batch transform is designed for offline processing of large datasets on a schedule, not for requests that arrive dynamically and require near real-time queuing. Watch for this clue in similar questions. Whenever a SageMaker scenario mentions large payloads, up to 1 GB, and long processing times, up to 60 minutes, that are not simple offline batches, choose asynchronous inference. Move to question number 3. Next, we enter the topic of Edge AI deployment. Review the scenario. A technology company is developing an offline-capable smart home device that requires built-in language understanding. The device has limited compute capacity and must respond to user commands with the absolute lowest latency without relying on internet connectivity. Which approach meets these requirements? The choices are: Option A, deploy optimized small language models, SLMs, locally on the edge devices. Option B, deploy multi-billion parameter large language models, LLMs, locally on the edge devices. Option C, route commands to a centralized small language model, SLM, API endpoint. Option D, route commands to a centralized large language model, LLM, API endpoint. The option that satisfies the complete requirement is A, deploy optimized small language models, SLMs, locally on the edge devices. The decisive reason is deploying an optimized small language model, SLM, directly on the edge device guarantees the lowest possible latency and allows the device to function offline without internet connectivity. SLMs require fewer compute resources, making them suitable for hardware-constrained edge environments. Check why each remaining option is not the best fit. B. Large language models, LLMs, require massive compute, memory, and storage, making them infeasible to deploy directly on typical edge hardware. C. A centralized API requires internet connectivity and introduces network latency, which violates the offline and lowest latency requirements. D. A centralized LLM API also requires connectivity and introduces network latency. Exam strategy. For strict latency constraints and offline capabilities on edge devices, favor deploying optimized small language models, SLMs, locally. For question number 4. Separate the requirement from the distractors. Look for the wording that eliminates the distractors. A data science team is building multiple machine learning models. The team needs a centralized repository to store, share, and reuse curated data attributes so that different models can use the same standardized inputs for training and inference. Which Amazon SageMaker capability should the team use? Compare the options by fit, not by familiarity. Next, option A, Amazon SageMaker Clarify. Next, option B, Amazon SageMaker Model Cards. Next, option C, Amazon SageMaker Data Wrangler. Next, option D, Amazon SageMaker Feature Store. After elimination, select D, Amazon SageMaker Feature Store. Amazon SageMaker Feature Store is a fully managed, purpose-built repository to store, update, retrieve, and share machine learning features. It ensures consistency across different models and teams by providing a centralized location for curated data attributes. Here is how to rule out the alternatives. A. SageMaker Clarify is used for detecting bias and explaining model predictions, not for storing features. B. SageMaker Model Cards are used to document model details, intended uses, and risk ratings for governance purposes. C. SageMaker Data Wrangler is a visual tool used to prepare and transform data, not a persistent repository for sharing features across teams. When you see the need to store, share, and reuse features or variables across ML teams, the answer is SageMaker Feature Store. Start by identifying the requirement in question number 5. The focus now shifts to ML learning types. First, locate the key operational constraint. An e-commerce platform has amassed petabytes of raw, unlabeled web browsing logs. The marketing department wants to group users with similar behaviors into distinct segments to target them with customized promotions. Which machine learning approach is appropriate for creating these segments? Now compare the choices one requirement at a time. Option A is reinforcement learning. Option B is supervised learning. Option C is unsupervised learning. Option D is reinforcement learning from human feedback, RLHF. The required response is C, unsupervised learning. This option satisfies the complete requirement because unsupervised learning is used to find hidden patterns or intrinsic structures in data that does not have labels. Grouping unlabeled user browsing logs into distinct customer segments is a classic clustering task, which is a type of unsupervised learning. Now eliminate the distractors. A. Reinforcement learning involves an agent interacting with an environment to maximize a reward signal, not categorizing unlabeled historical data. B. Supervised learning requires labeled training data, input-output pairs, to learn how to predict a specific target, which is not available in this scenario. D. RLHF is used to align foundation models with human preferences, not for clustering raw customer data. A useful exam pattern is this. If a dataset is described as unlabeled and the goal is to group, cluster, or segment the data, choose unsupervised learning. Question number 6. Tests careful elimination. Identify the decisive constraint before considering the options. An organization is building an internal search engine for its engineering documentation. The system must allow users to query and retrieve both text manuals and architectural diagrams simultaneously. Which type of foundation model is required to support this search application? Watch for distractors that are valid services but wrong for this scenario. Consider option A, multimodal generation model. Consider option B, image generation model. Consider option C, text embedding model. Consider option D, multimodal embedding model. The correct choice is D, multimodal embedding model. The requirement to solution match is an embedding model converts data into numerical vectors so they can be indexed and searched by similarity. A multimodal embedding model can process more than one data type, modality, such as both text documents and images, diagrams, mapping them into the same semantic vector space. The incorrect choices are plausible, but unsuitable because A. A generation model produces new content rather than converting existing data into search index vectors. B. An image generation model creates new images from text prompts, it does not perform search indexing. C. A text embedding model can only process text, so it cannot index the architectural diagrams. Use this elimination rule in the exam. Embedding models are foundational for semantic search. If the search involves multiple data types, for example, text and images, you need a multimodal embedding model. Approach question number 7. By checking every constraint. We are moving to AI use case selection. Pay attention to qualifiers such as least, most, and minimum. A cybersecurity team wants to use machine learning to identify abnormal network traffic patterns that could indicate a distributed denial of service, DDoS, attack or an unauthorized intrusion. Which type of AI system should the team build? Eliminate every option that violates even one requirement. Next, option A, fraud forecasting system. Next, option B, named entity recognition, NER, system. Next, option C, anomaly detection system. Next, option D, speech recognition system. The option that satisfies the complete requirement is C, anomaly detection system. Here is the reasoning that confirms the answer. Anomaly detection is an ML technique used to identify rare items, events, or observations that deviate significantly from the majority of the data. Identifying suspicious IP addresses or unusual network patterns is a primary use case for anomaly detection. The remaining options fail one or more requirements because A. Fraud forecasting systems typically focus on financial transactions or e-commerce chargebacks rather than core network packet analysis. B. Named entity recognition, NER, extracts information like names and locations from natural language text. D. Speech recognition converts spoken language into text. Remember this decision rule. Security monitoring, network intrusion, and equipment failure use cases are classically solved using anomaly detection. Focus on the key wording in question number 8. This scenario tests whether you recognize the controlling constraint. A financial institution uses an ML model to determine credit limits. Compliance officers require documentation that explains how different input variables, such as income and credit score, influence the model's final predictions. Which output provides the necessary transparency and explainability? The exam distinction is hidden in these choices. Now examine choice A, the source code used for model training. Now examine choice B, model convergence tables. Now examine choice C, the raw training dataset. Now examine choice D, partial dependence plots, PDPs. The best answer is D, partial dependence plots, PDPs. The key clue points here because partial dependence plots, PDPs, show the marginal effect one or two features have on the predicted outcome of a machine learning model. They are a standard tool used in responsible AI to provide explainability to stakeholders regarding how inputs affect decisions. A source code shows how the infrastructure is programmed, but it does not explain how the trained model's internal logic weighs specific inputs during inference. B. Convergence tables show the training loss over time to prove the model learned, but do not provide explainability for the final predictions. C. Raw training data shows the inputs but provides no insight into how the ML model interprets that data to make decisions. Watch for this clue in similar questions. To satisfy explainability or interpretability requirements regarding how features impact predictions, look for PDPs, SHAP values, or feature importance metrics. Let's break down question number 9. This question moves us into AI use case selection. Start by separating the facts from the requirement. A healthcare provider wants to use a large language model, LLM, to review lengthy patient consultation transcripts and generate brief, high-level overviews of the medical findings. Which application should the provider develop? Review the options and eliminate any clear mismatch. Choice A, a summarization chatbot. Choice B, a multilanguage translation system. Choice C, an automatic named entity recognition system. Choice D, a recommendation engine. After elimination, select A, a summarization chatbot. The decisive reason is summarization is a natural language processing task that condenses lengthy documents into brief overviews while retaining the most important information. This exactly matches the requirement to extract key points from long medical transcripts. Check why each remaining option is not the best fit. B. Translation systems convert text from one language to another, not condense it. C. Named entity recognition, NER, extracts specific nouns, like drug names or patient names, but does not provide a narrative overview or summary of the entire document. D. A recommendation engine suggests products or content based on user preferences. Exam strategy. When the goal is to condense long documents, articles, or transcripts into brief overviews, the correct NLP task is summarization. Work through question number 10. Step by step. Read the scenario with the target outcome in mind. A company creates an Amazon Bedrock knowledge base with documents stored in an Amazon S3 data source. The documents are encrypted at rest with Amazon S3 Managed Keys, SSES3. During data source synchronization, Amazon Bedrock cannot read the S3 objects. How can the company resolve this access issue? Use the scenario constraints to assess these choices. Option A is ensure the S3 data does not contain personally identifiable information, PII. Option B is ensure the IAM role assumed by Amazon Bedrock has permission to read the S3 objects. Option C is modify the prompt to explicitly instruct the model to search Amazon S3. Option D is make the S3 bucket publicly accessible to allow Bedrock internet access. The required response is B. Ensure the IAM role assumed by Amazon Bedrock has permission to read the S3 objects. An Amazon Bedrock knowledge base uses a service role to access its S3 data source. The role needs permissions such as S3, get object for the required objects. With SSCS3, Amazon S3 transparently decrypts data for an authorized request. A separate KMS decrypt permission is not required. Here is how to rule out the alternatives. A. PII handling is a privacy concern, but PII does not cause an S3 authorization failure. C. Prompt instructions cannot grant AWS permissions or bypass IAM controls. D. Public access is unnecessary and would weaken security. Bedrock should access private objects through an authorized IAM role. For Bedrock access to private S3 data, check the service role and bucket permissions. Add KMS, decrypt only when a customer-managed KMS key is involved. Question number 11 contains an important exam distinction. This question moves us into AI service selection. The key exam clue is contained in this scenario. A software engineering team wants to accelerate its application development lifecycle. The team needs an AI-powered tool that integrates into their IDE to generate code snippets, explain existing logic, and identify open-source licenses. Which AWS service provides these capabilities? The exam distinction is hidden in these choices. Now examine choice A, Amazon Transcribe. Now examine choice B, AWS Fargate. Now examine choice C, Amazon Q Developer. Now examine choice D, Amazon LEX. After elimination, select C, Amazon Q Developer. This option satisfies the complete requirement because Amazon Q Developer is an AI-powered assistant that integrates directly into IDEs to help developers write code, understand logic, debug issues, and track open-source software licenses, significantly improving developer productivity. Now eliminate the distractors. A. Amazon Transcribe converts spoken audio into text. B. AWS Fargate is a serverless compute engine for containers, not an AI coding assistant. D. Amazon LEX is used to build conversational chatbots for customer service applications, not IDE coding assistants. A useful exam pattern is this. For developer productivity, IDE integration, code snippet generation, and license tracking, the correct service is Amazon Q Developer. Question number 12. Scenario. A government agency is building a generative AI workflow using Amazon Bedrock. Due to strict data privacy mandates, the architecture is deployed within an isolated VPC, and all API calls to Amazon Bedrock must route internally without traversing the public internet. Which AWS feature should the agency configure to enable this private connectivity? Review the options. Choice A, Amazon Macy. Choice B, AWS Private Link. Choice C, Internet Gateway. Choice D, Amazon CloudFront. The correct choice is B, AWS Private Link. The requirement to solution match is AWS Private Link provides private connectivity between VPCs, AWS services, and your on-premises networks. By configuring VPC endpoints for Amazon Bedrock, all API traffic between the VPC and Bedrock stays on the private AWS network and never traverses the public internet, satisfying strict compliance mandates. The incorrect choices are plausible, but unsuitable because A. Amazon may see uses machine learning to discover and protect sensitive data in S3, not to route network traffic. C. An internet gateway explicitly allows traffic to traverse the public internet, which violates the regulatory requirement. D. Amazon CloudFront is a global content delivery network, CDN, used to accelerate web traffic over the internet. Use this elimination rule in the exam. Whenever a requirement dictates that AWS service API calls must not traverse the public internet, the solution always involves AWS private link, VPC endpoints. Let's analyze question number 13. Next, we enter the topic of AI use case selection. Start by separating the facts from the requirement. A developer is creating a basic web application that calculates the standard deviation of a user-provided list of 10 integers. The application needs to return the correct mathematical result as quickly and cheaply as possible. Which implementation method requires the least operational overhead? Use the scenario constraints to assess these choices. Option A is train a reinforcement learning agent to estimate the calculation. Option B is deploy a regression model using supervised learning to predict the standard deviation. Option C is write deterministic code that applies the mathematical formula directly. Option D is use unsupervised learning to cluster the integers and estimate the density. The option that satisfies the complete requirement is C, write deterministic code that applies the mathematical formula directly. Here is the reasoning that confirms the answer. Standard deviation is calculated by a fixed mathematical formula. Deterministic code returns the exact result with less cost, complexity, and operational overhead than training or hosting an ML model. The remaining options fail one or more requirements because A. Reinforcement learning requires an environment, actions, rewards, and repeated training, which is unnecessary for an exact formula. B. A regression model would require training data and could introduce prediction error into a deterministic calculation. D. Unsupervised learning can find patterns in unlabeled data, but clustering does not calculate an exact statistical formula. Remember this decision rule. When fixed rules or formulas produce the required exact result, use deterministic software rather than AI or ML. Question number 14. Is a good test of exam judgment. The key exam clue is contained in this scenario. A retail company integrated a large language model, LLM, into its website to answer customer questions. Currently, the LLM provides long, detailed answers in English. The company wants the model to output concise answers exclusively in Spanish. Which approach is the simplest way to align the outputs with these requirements? Focus on which option satisfies the complete requirement. Option A. Adjust the system prompt to specify the language and length constraints. Option B. Increase the model's top K parameter. Option C. Increase the model's temperature parameter. Option D. Migrate to a foundation model with a larger parameter count. The best answer is A. Adjust the system prompt to specify the language and length constraints. The key clue points here because prompt engineering is the easiest and most direct way to control the output format, length, and language of a foundation model without changing any code or infrastructure. Updating the system prompt to demand concise Spanish responses directly addresses the requirement. B. Top K limits the vocabulary choices during generation to reduce weird outputs, but it does not enforce a specific language or length constraint. C. Increasing temperature makes the model's output more random and creative, which does not guarantee brevity or Spanish output. D. Migrating to a larger model is more expensive, requires operational changes, and still requires prompt engineering to enforce specific constraints. Watch for this clue in similar questions. To change the formatting, tone, length, or language of an LLM's response with the least effort, always adjust the prompt first before altering parameters or models. Question number 15 contains an important exam distinction. We are moving to model customization. This scenario tests whether you recognize the controlling constraint. A computer vision startup wants to build a model that detects rare manufacturing defects. To save time and computational resources, the team plans to take an existing model trained on general objects and adapt it to their specific defect dataset. Which machine learning technique describes this approach? Focus on which option satisfies the complete requirement. Option A, unsupervised learning. Option B, transfer learning. Option C, increasing the number of epochs. Option D, decreasing the number of epochs. The required response is B, transfer learning. The decisive reason is transfer learning is a machine learning technique where a model developed for one task is reused as the starting point for a model on a second, related task. This allows teams to adapt pre-trained models to new datasets without the heavy computational cost of training from scratch. Check why each remaining option is not the best fit. A. Unsupervised learning finds patterns in unlabeled data. It is not a technique for reusing pre-trained model weights. C. Increasing epochs during training simply trains the current model longer. It is not the methodology for transferring knowledge between tasks. D. Decreasing epochs stops training earlier, which does not describe the process of adapting a model. Exam strategy. Adapting a pre-trained model to a new but related task is the exact definition of transfer learning, which includes fine-tuning. Focus on the key wording in question number 16. Focus on the requirement that drives the design choice. A medical research facility is generating a dataset of annotated X-ray images to train a diagnostic model. The annotations must be highly accurate, and the team needs to ensure that any ambiguous images are manually reviewed by subject matter experts. Which AWS service or feature supports this workflow? The exam distinction is hidden in these choices. Now examine choice A, Amazon Bedrock knowledge bases. Now examine choice B, Amazon Recognition custom labels. Now examine choice C, Amazon QuickSight Q. Now examine choice D, Amazon SageMaker Ground Truth Plus. The correct choice is D, Amazon SageMaker Ground Truth Plus. Amazon SageMaker Ground Truth Plus is a fully managed data labeling service that provides an expert workforce, human in the loop, to create high-quality training datasets. It is explicitly designed to minimize annotation errors and ensure high accuracy for machine learning datasets. Here is how to rule out the alternatives. A. Bedrock knowledge bases are used for RAG to provide LLMs with external data, not for labeling images. B. Recognition custom labels is used to train custom vision models, but the question asks how to create the perfectly labeled dataset first, specifically requesting human review. C. QuickSight Q allows users to ask natural language questions about business intelligence dashboards. For data labeling tasks that require high accuracy and human-in-the-loop validation, choose SageMaker Ground Truth or Ground Truth Plus. Let's break down question number 17. The focus now shifts to model evaluation. Review the scenario and identify what must be achieved. An IT operations team is monitoring a newly deployed natural language processing model that powers a live customer chat interface. The team needs to ensure the model responds quickly enough to maintain a natural conversational flow. Which metric best measures the runtime efficiency of the deployed model? Review the options and eliminate any clear mismatch. Choice A, average response time. Choice B, number of training instances. Choice C, customer satisfaction score, CSAT. Choice D, training time for each epoch. After elimination, select A, average response time. This option satisfies the complete requirement because average response time, latency, is an operational metric that directly measures the runtime efficiency of a deployed model. In a live chat interface, low response times are critical for maintaining a seamless user experience. Now eliminate the distractors. B. Number of training instances is a measure of dataset size, not live operational runtime efficiency. C. CSAT is a business metric that measures user satisfaction, not the technical runtime efficiency of the underlying infrastructure. D. Training time measures how long it takes to build the model, not how fast it executes inferences in production. A useful exam pattern is this. Distinguish between training metrics, loss, epochs, evaluation metrics, accuracy, F1, and operational metrics, latency, throughput. Focus on the key wording in question number 18. The key exam clue is contained in this scenario. A customer service department records thousands of phone calls daily. The management team wants to analyze these recordings to identify common support issues, which requires converting the spoken audio into searchable text documents. Which AWS service should the company use to perform this conversion? The exam distinction is hidden in these choices. Option A, Amazon Transcribe. Option B, Amazon Comprehend. Option C, Amazon SageMaker Model Monitor. Option D, Amazon LEX. The option that satisfies the complete requirement is A, Amazon Transcribe. The requirement to solution matches Amazon Transcribe is an automated speech recognition, ASR, service that converts spoken audio into searchable text, making it the perfect solution for processing customer phone call recordings. The incorrect choices are plausible, but unsuitable because B. Amazon Comprehend performs natural language processing, NLP, on text, but it requires text as an input and cannot process audio files. C. SageMaker Model Monitor evaluates models in production for data drift. It does not perform audio transcription. D. Amazon LEX builds conversational interfaces, chatbots. While it has speech recognition, it is not used for batch processing thousands of historical audio files into transcripts. Use this elimination rule in the exam. If the source data is audio or voice and needs to be analyzed, Amazon Transcribe must be used first to convert the audio into text. Question number 19. Find the decisive clue before choosing. Next, we enter the topic of AI explainability. Pay attention to qualifiers such as least, most, and minimum. A heavily regulated bank is developing an ML model to approve or deny loan applications. Regulators mandate that the bank must be able to visually document and trace the exact logical path and conditions the model followed to reach every individual decision. Which machine learning algorithm is inherently interpretable and meets this requirement? Compare the options by fit, not by familiarity. Consider option A, logistic regression. Consider option B, decision trees. Consider option C, deep neural networks. Consider option D, linear regression. The required response is B, decision trees. Here is the reasoning that confirms the answer. Decision trees are inherently interpretable machine learning algorithms. They use a branching, rule-based structure that humans can easily read and audit to see exactly which conditions led to a specific prediction. The remaining options fail one or more requirements because A. Logistic regression provides weights for features but is less visually traceable for non-technical auditors than a simple decision tree. C. Deep neural networks are highly complex, black box models that do not provide clear internal transparency regarding how individual decisions are reached. D. Linear regression is for continuous numerical outputs, not classification, approving or denying loans. Remember this decision rule. When strict transparency and human-readable, auditable decision paths are required, tree-based models, decision trees, are often preferred over deep learning neural networks. Question number 20. Find the decisive clue before choosing. Look for the wording that eliminates the distractors. A marketing agency wants to fine-tune a foundation model, FM, on Amazon Bedrock so that it generates copy matching the agency's brand voice. The agency has thousands of historical user requests and corresponding approved marketing responses. How should the agency provide this data for supervised fine-tuning? Eliminate every option that violates even one requirement. Consider option A. Supply a labeled JSON dataset that pairs each user request with its approved target response in the format required by the selected model. Consider option B. Supply a CSV file of raw, unpaired journal entries. Consider option C. Purchase provision throughput without uploading training data. Consider option D. Upload unrelated, unlabeled textbook files for continued pre-training. The best answer is A. Supply a labeled JSON dataset that pairs each user request with its approved target response in the format required by the selected model. The key clue points here because Amazon Bedrock fine-tuning uses JSON lines training data whose records follow the schema required by the chosen model. Aligned request and approved response examples provide the supervised targets needed to teach the desired brand style. B. Raw, unpaired entries do not provide the target responses required for supervised fine-tuning and might not use a supported schema. C. Provision throughput supplies inference capacity. It does not customize a model without a training job and dataset. D. Unrelated, unlabeled corpora are not suitable supervised examples for reproducing the agency's brand voice. Watch for this clue in similar questions. Bedrock fine-tuning uses labeled JSON examples, but the exact record schema depends on the selected foundation model. Question number 21 contains an important exam distinction. This scenario tests whether you recognize the controlling constraint. A data engineering team is building a retrieval augmented generation (RAG) architecture. They need a managed database solution capable of storing high-dimensional embeddings and performing similarity queries against them. Which capability of Amazon OpenSearch service supports this requirement? Focus on which option satisfies the complete requirement. Now examine choice A, scalable index management and nearest neighbor search. Now examine choice B, integration with Amazon S3 for archival object storage. Now examine choice C, real-time analysis of streaming server logs. Now examine choice D, support for geospatial tracking queries. After elimination, select A, scalable index management and nearest neighbor search. The decisive reason is Amazon OpenSearch service supports K-nearest neighbor (KNN) search capabilities. This allows developers to index high-dimensional vectors, embeddings, generated by foundation models and rapidly query them for semantic similarity, which is the core requirement for our AG architectures. Check why each remaining option is not the best fit. B. S3 integration is useful for backups, but it does not enable the vector similarity search capability. C. Real-time analysis of streaming logs is a primary OpenSearch feature, but it is not the feature used for vector embedding similarity matching. D. Geospatial queries search physical locations, latitude-longitude, not semantic embeddings. Exam strategy. Vector databases rely on k-nearest neighbor, KNN, search to find embeddings that are mathematically close to a user's query. Amazon OpenSearch service provides this natively. Question number 22. Tests careful elimination. Identify the decisive constraint before considering the options. A company is exploring ways to adopt AI across its various departments. The leadership team wants to identify a project that leverages generative AI capabilities rather than traditional predictive machine learning. Which scenario is a valid use case for generative AI? Watch for distractors that are valid services but wrong for this scenario. Next, option A, using an intrusion detection system to block malicious network traffic. Next, option B, forecasting future supply chain bottlenecks based on historical data. Next, option C, generating realistic background images from text prompts for product catalogs. Next, option D, optimizing database indexing to improve query read speeds. The correct choice is C, generating realistic background images from text prompts for product catalogs. Generative AI creates new content such as text, images, audio, or video. Producing a new catalog background image from a text prompt is therefore a direct generative AI use case. Here is how to rule out the alternatives. A. Blocking malicious traffic is generally an anomaly detection or classification use case. B. Predicting supply chain bottlenecks from historical data is a forecasting use case. D. Improving database indexes is a database engineering and optimization task, not a content generation task. Generative AI creates new content. Traditional ML commonly classifies, predicts, clusters, detects anomalies, or forecasts. For question number 23. Separate the requirement from the distractors. This question moves us into tokens and context. Identify the decisive constraint before considering the options. An AI developer is evaluating different foundation models, FMs, on Amazon Bedrock for a document summarization task. The application must process 50-page legal contracts in a single request. Which model specification dictates the maximum amount of text that can be provided in a single prompt? Compare the options by fit, not by familiarity. Consider option A, context window. Consider option B, batch size. Consider option C, temperature. Consider option D, model parameters. The best answer is A, context window. This option satisfies the complete requirement because the context window defines the maximum number of tokens, words or subwords, a foundation model can process in a single interaction. This includes the prompt, external data, like a 50-page document, and the generated output. Now eliminate the distractors. B. Batch size refers to how many inputs are processed simultaneously during training or inference, not the length limit of a single prompt. C. Temperature controls the randomness or creativity of the model's output. D. Model parameters represent the size and complexity of the model's internal neural network weights, not the input length limit. A useful exam pattern is this. If a scenario asks about fitting large documents, chat histories, or extensive instructions into a single prompt, the determining factor is the model's context window. Approach question number 24. By checking every constraint. Look for the wording that eliminates the distractors. A healthcare startup is deploying an AI assistant powered by a foundation model. The assistant currently provides accurate answers but often uses casual slang. The startup needs the assistant to strictly use formal, empathetic, and professional language without requiring a model retraining process. Which approach meets these requirements? Watch for distractors that are valid services but wrong for this scenario. Next, option A, increase the inference temperature parameter to a higher value. Next, option B, implement batch inferencing to aggregate responses. Next, option C, lower the maximum token count parameter. Next, option D, experiment and refine the system prompt to dictate the required tone. The option that satisfies the complete requirement is D, experiment and refine the system prompt to dictate the required tone. The requirement to solution matches a system prompt can define tone, persona, language, and formatting constraints without changing model weights. Refining it to require formal, empathetic, and professional language is the least invasive approach in this scenario. The incorrect choices are plausible, but unsuitable because A, increasing temperature generally increases output variability and does not enforce a professional tone. B, batch inference changes how requests are processed, not the linguistic style of responses. C, reducing the output token limit controls response length but does not prevent slang. Use this elimination rule in the exam. For tone, persona, language, or formatting changes, refine the system prompt before considering model customization. Question number 25. Find the decisive clue before choosing. The focus now shifts to few-shot prompting. Pay attention to qualifiers such as least, most, and minimum. An application uses a large language model, LLM, on Amazon Bedrock to categorize support tickets as billing, technical, or general. The development team wants to improve classification accuracy using a prompt engineering technique. How can the team apply few-shot prompting for this task? Eliminate every option that violates even one requirement. Consider option A, include several examples of tickets and their correct category labels in the prompt before the new ticket. Consider option B, provide a detailed dictionary definition of what constitutes a billing issue within the prompt. Consider option C, pass the text of the new ticket to the model without any surrounding context or instructions. Consider option D, provide examples of unrelated tasks, such as translating English to French, before the new ticket. The required response is A, include several examples of tickets and their correct category labels in the prompt before the new ticket. Here is the reasoning that confirms the answer. Few-shot prompting involves passing a small number of example input-output pairs to the foundation model within the prompt itself. This teaches the model the desired format and classification logic just in time, significantly improving accuracy on the target task. The remaining options fail one or more requirements because B, providing a dictionary definition is an example of zero-shot prompting with explicit instructions, not few-shot prompting. C, passing text with no context or examples is standard zero-shot prompting. D, providing unrelated tasks will confuse the model and degrade performance. Few-shot examples must be relevant to the target task. Remember this decision rule. Few-shot prompting explicitly requires placing examples of the desired input and correct output inside the prompt before asking the model to process the new data. Question number 26. Is a good test of exam judgment. Focus on the requirement that drives the design choice. A cloud administrator is auditing an organization's Amazon Bedrock usage. The administrator needs to review a log of all API calls made to invoke models over the past 30 days to identify any unauthorized access attempts. Which AWS service provides the historical API call records required for this audit? Focus on which option satisfies the complete requirement. Now examine choice A, Amazon Fraud Detector. Now examine choice B, AWS Trusted Advisor. Now examine choice C, AWS Cloud Trail. Now examine choice D, AWS Audit Manager. After elimination, select C, AWS Cloud Trail. The key clue points here because AWS Cloud Trail is a governance and auditing service that records API activity across an AWS account. It logs exactly who made an API request, including Bedrock model invocations, what IP address the request originated from, and when it occurred. A. Amazon Fraud Detector uses ML to identify fraudulent activities like fake account creations, not to audit AWS internal API logs. B. AWS Trusted Advisor provides best practice recommendations for cost optimization, security, and performance, but is not an API auditing log. D. AWS Audit Manager helps continuously audit AWS usage to map to compliance frameworks, but the underlying raw API logs are sourced from CloudTrail. Watch for this clue in similar questions. For auditing API calls, tracing user actions, and investigating unauthorized access attempts on AWS, AWS CloudTrail is the answer. Work through question number 27. Step by step. We are moving to AI compliance. Read the scenario with the target outcome in mind. A compliance officer at a financial technology company needs to monitor the regulatory status of the company's cloud infrastructure. The officer wants to be notified automatically when new compliance reports and security audits for AWS and third-party software vendors become available. Which AWS service can the officer use to access these reports? Check each option against the exact requirement. Choice A, AWS Trusted Advisor. Choice B, AWS Artifact. Choice C, AWS Audit Manager. Choice D, AWS Data Exchange. The option that satisfies the complete requirement is B, AWS Artifact. The decisive reason is AWS Artifact is the central resource for compliance-related information. It provides on-demand access to AWS security and compliance reports like SOC and PCI, and select online agreements. Artifact notifications can be set up to alert users when new reports are published. Check why each remaining option is not the best fit. A. Trusted Advisor provides account configuration checks against best practices, not official third-party compliance audit reports. C. Audit Manager helps customers automate their own evidence collection for audits. It does not distribute AWS's own certification reports. D. Data Exchange is a marketplace to find and subscribe to third-party data in the cloud, not a repository for AWS compliance reports. Exam strategy. When you need to download official compliance reports, SOC, PCI, ISO, or sign agreements like above, you must use AWS Artifact. For question number 28. Separate the requirement from the distractors. Look for the wording that eliminates the distractors. A developer is deploying a public-facing conversational AI agent. The developer is concerned that malicious users might use specialized input techniques to override the system instructions and force the model to expose backend configuration details. Which mitigation strategy will help reduce this risk? Compare the options by fit, not by familiarity. Next, option A, avoid using language models that are available outside of Amazon SageMaker. Next, option B, increase the inference temperature parameter to maximize output variance. Next, option C, design a prompt template that guides the model to detect and reject attack patterns. Next, option D, decrease the maximum allowed output tokens to strictly limit response length. The correct choice is C, design a prompt template that guides the model to detect and reject attack patterns. Prompt injection occurs when users provide inputs designed to override the application's intended instructions. Creating robust prompt templates that instruct the model to ignore malicious overrides or applying constraints, such as guardrails, is a primary mitigation strategy. Here is how to rule out the alternatives. A. Prompt injection is a fundamental risk of all large language models, regardless of whether they are hosted on SageMaker, Bedrock, or externally. B. Increasing temperature increases randomness, which can make the model more susceptible to hallucination and less adherent to security constraints. D. Decreasing output tokens truncates the response but does not prevent the model from executing a prompt injection payload or exposing restricted data within that limit. Defending against prompt injection requires robust prompt engineering, clear system instructions to reject overrides, and the use of filtering tools like guardrails for Amazon Bedrock. Approach question number 29. By checking every constraint. Identify the decisive constraint before considering the options. A Chief Information Security Officer, CISO, is reviewing the Generative AI Security Scoping Matrix to understand the organization's responsibilities across different implementation strategies. Which generative AI deployment model requires the customer to assume the maximum amount of security and operational responsibility? Eliminate every option that violates even one requirement. Next, option A, using an existing third-party generative AI foundation model hosted by a vendor. Next, option B, fine-tuning a managed generative AI foundation model with company-specific data. Next, option C, adopting a third-party enterprise SaaS application with embedded generative AI features. Next, option D, building, training, and hosting a generative AI foundation model from scratch using raw compute infrastructure. The best answer is D, building, training, and hosting a generative AI foundation model from scratch using raw compute infrastructure. This option satisfies the complete requirement because under the AWS shared responsibility model, building a foundation model from scratch, infrastructure as a service, requires the customer to manage everything from the underlying OS security, networking, data collection, model training, and continuous governance. This demands the highest level of customer ownership. Now eliminate the distractors. A. Using a third-party hosted model shifts most infrastructure and model security responsibilities to the vendor. B. Fine-tuning a managed model, like on Bedrock, shifts infrastructure, base model training, and security patching to AWS. Using an embedded SaaS feature places almost all security and operational responsibility on the SaaS provider. A useful exam pattern is this. The more managed a service is, SaaS, PaaS, IaaS, the less operational responsibility the customer has. Building from scratch always yields the maximum customer responsibility. You have completed part 1 of the AIF-C01 exam practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.